So if there's no questions on the assignment, we're going to go on and look at today's lesson. Now today's lesson, tomorrow and Wednesday, are going to be continuing with solving because we started that last Thursday. Now unlike last Thursday, today the bases aren't going to be the same, and there's no way for us to be able to make them be the same. Because 2 and 7, there's no way I can rewrite 7 as 2 to a power, or to a nice whole number power, because it just doesn't work. But what we're going to utilize is a certain property, because our log base b of b, whenever the base and what's inside are the same, this simplifies to 1. Whenever the base and what's inside the logarithm are the same, they simplify to 1. And we're going to apply this whenever we have a variable inside of an exponent and only one thing on either side. So here we have 2 to the x equals 7. So what we can do is take it, 2 to the x, and 7, and apply log base 2 to both sides. So what we get is log base 2 of 2 to the x is equal to log base 2 of 7. Now, according to our exponential or power properties, we can move the exponent out front, telling us that we have x times log base 2 of 2 is equal to log base 2 of 7. So we use the fact that if the base and what's inside the same, it'll simplify to 1, and our power property, which states we can move the exponents out front. Now, if we looked at this here, we'll go back to that screen in a minute. But if I type in log base 2 of 2, we get 1. So what that means for us here is that this here is going to simplify to 1. And 1 times x is just x. Now on the other side, we still have log base 2 of 7. So the last thing we need to do is just calculate what log base 2 of 7 is. We can use the change of base that we learned last week, or we can type it into the graphing calculator, go math, log base 2, yep, 7, 2.807. We'll go 3 decimal places. So here x is approximately 2.807. And that's it. So it is possible to write 2 to a power and get 7. It's just that exponent is not going to be a rational number. Any questions on any of this here? Be ready for the next one. Now looking at this here, we have 3 to the x equals 8. So what can we do first in solving for the value of x? Right, we can apply log base 3 to both sides. Because since we only have one term on either side, 3 to the x is a single term, 8 is a single term, we can go on and apply this log base 3 to both sides. On the left-hand side, the x is going to move out front, telling us that we have x times log base 3 of 3 is equal to log base 3 of 8. And as we saw in the last one here, log base 3 of 3 simplifies to 1, leaving us with x by itself is equal to log base 3 of 8. Eight, 9, 3, because the number after it would be greater than 5. And that's it. Now, a lot of these here, especially on the test, I would go on and especially rewrite out log base, whatever you have. Write this eraser. I want a highlighter. I would definitely include this as part of your answer, especially on the test. Because, again, as we all know, the calculators can sometimes be a little finicky and not give you the correct answer just because you typed it in wrong. You didn't include a parentheses, you included an extra negative where there shouldn't have been. Or instead of writing a negative, you put in a, or instead of putting in a subtraction, you put in a negative. It's going to change the answer. If you at least write this, I will know that you got to the right answer. Just the calculator or something went wrong when you were plugging it in. Does that make sense? So, any questions on this here? Is this as bad as what it looked like? So this one here, there's two ways we can do it. One of them is we can hit math, and I go up, because you can go up or down to log base 3 of 8. And we get this here. Now, according to the change of base, we can say log of 8, close parentheses, over log of 3, and get the same thing. We can use the change of base to type it in as well. Any other questions on this here? Any questions over anything we've done so far? Let's look at the next one. So the next one we have is 7 to the 9x equals 15. What can we do first? Or what can we apply to both sides? Log base 7. 7 to the 9x equals log base 7 of 15. And the reason we're doing this is we're applying log to get this exponent to go out front. Because any time we have something inside of an exponent to inside the logarithm to an exponent, we can move the exponent out front, telling us that we have 9x times log base 7 of 7 equals log base 7 of 15. And we know that whenever the base and what's inside the logarithm are the same, it reduces it to 1. Really telling us that 9x equals log base 7 of 15. Yes. Is x by itself? No. So here we have to take it one step further and divide both sides by 9. Telling us x is log base 7 of 15 over 9, which is approximately you have one more decimal for me? 0.155. 0.155. That makes more sense because that number is going to be small. Any questions over any of this here? Any questions over anything we've done so far? So with having 9x in the exponent, did that really change what we did? No. First step was the same, then the rest of it is just using algebra to get it by itself. This here is the last one we'll look at of this type, and then we'll kind of move on to the next group. So looking at this one here, we have 5 to the 3x plus 7 equals 311. Now we do only have one thing on either side, so what can we do first? We can apply log of what? Base 5 of 5 to the 3x equals log base 5 of 311. And the reason we're doing this is because log base 5 of 5 simplifies to what? 1. It simplifies to 1. And that exponent's going to be moved out front. Telling us that we have 3x plus 7, yes? Well, what is log base 5 of 5? It is 1. Do I need to rewrite it? No, because we know that this is gone, giving us log base 5 of 311. Now, log base 5 of 311, we know is just a number, yes? It has a specific value. So we can continue to use our operations on this. And with any of these here, I would wait to the very end to type it all in. I would wait to the very end to type everything in so that we're not having to approximate. Because as we've seen so far, these logs do not give us nice numbers. There's a few that do, but most don't. So to get x by itself, what would we do next? Subtract 7 from both sides. And here, 7 minus 7 is 0, giving us 3x equals log base 5 of what? It's actually a trick question. It's still 311 minus 7. Because that log base 5 of 311, that is inside those parentheses. That is attached to the log. The negative 7 is not. So it stays on the outside. Then what would we do next? Divide both sides by 3. Which tells us that x is equal to log base 5 of 311 minus 7 over 3. And again, so the ones at the start, rewriting this part out did seem like a whole lot necessary because it's not too bad to type in, say log base 5 of 311. That's not too bad to type in. This here is where we can again get a little bit more mistakes or something comes up just by typing it in. So it's good to have that there. So in the calculator, we can go alpha y equals, enter, math, log base 5 of 311 minus 7 divided by 3, we get negative 1.145. And that's our answer. And again, what's inside an exponent can be positive, it can be negative, and it can be 0. So having x be a negative for these here is fine because it's going into the exponent. It's not going inside of a log. Any questions on any of this here? I have a feeling we feel comfortable with this for this here so far, yes? Let's go on and move on to the next type. Is these here. Now the big difference is, one, we have e included in this here. So we won't be using logs, we'll actually be using the natural logs, because a natural log will simplify e. Also, before we can apply the natural log, we need to get e by itself first. And that's true with the ones before. We didn't have anything else around them, but we do need to get it by itself. So looking at this problem here, what's the first thing we can do to get e by itself? We can add 7 to both sides. And if we add 7 to both sides, negative 7 plus 7 is 0, telling us that we have 4e to the negative 0.3x equals 20. Is e by itself? No. So what do we need to do next? Divide both sides by 4. 4e to the negative 0.3x divided by 4 is e to the negative 0.3x equals 5. Now all the ones up to this point so far, we've been applying a log where the base and what's inside or attached to this as a variable in the exponent are the same. Now we could say that here, at this point here, we apply log base e to both sides. which would be true. That would be the correct statement. But instead of writing log, we actually just write ln. Because the natural log's base is understood to be e. On the left-hand side, the negative 0.3x should move out front, telling us that negative 0.3x times the natural log of e is equal to the natural log of 5. And ln of e is 1. This simplifies to 1, telling us that negative 0.3x equals the natural log of 5. What can we do at this point here? Divide by negative 0.3. Turn the page a little bit, which tells us that x is equal to ln of 5 over negative 0.3. Well, at this point here, these are a little bit nicer to type in instead of the ones we've had up to this point, because in the calculator, we can go alpha y equals enter for our fraction and say ln of 5 over negative 0.3. Because whenever the base is 10, or e we're just using ln. If it's 10, we just use the log button. We don't have to use the log base. So here our answer is negative 5.365. That's it. That's all we have to do it, because at that point we're just typing it into the calculator. Any questions on any of this here? Any questions on everything we've done so far? Are we ready for the next one? So again, it's just like the one we had before. We need to get e by itself. So what can we do first? We can? Yeah, we can add 4 to both sides. Because negative 4 plus 4 is 0, telling us 3e to the x equals 8 plus 4 is. What can we do next? Divide by 3. Because again, we need e by itself. Whenever we're using or applying logs to both sides, we need to have one term on either side, and as simplified as we can get. And 12 divided by 3 is 4. Any questions on how we got e to the x equals 4? So what can we do next? We can apply the natural log to both sides, which will tell us that we have ln of e to the x equals ln of 4. Well, here we know the x moves out front. So we have x ln of e equals ln of 4. And ln of e we know is 1, telling us x is equal to the natural log of 4, or that's it. Any questions on any of these here? Any questions over anything we've done so far? This one here is actually not as bad as it looks. The only big difference between this here and what we did before is we don't actually have to add or subtract anything before we apply the logs. We have to do it afterwards. Because here is e already by itself. Well, yes. So we could say that ln of e to the 4x minus 3 is equal to ln of 19. Well, we know this entire exponent is going to move out front, yes? What's the natural log of e? 1, yes? So this here is gone. The only thing left on the left-hand side is the 4x minus 3. It's the exponent. That's why we're applying that natural log. We're trying to get it to go away. On the other side, we have the natural log of 19. Now we just need to get x by itself. So the first thing we can do is add 3 plus 3 to both sides, which will tell us that 4x equals the natural log of 19 plus 3. Yes, x is still not by itself, so we have to divide both sides by 4. Telling us x is equal to natural log of 19 plus 3 over 4, or 1.486. And that's it. And you made sure to put parentheses around that 19. Yep. And again, this here, why I say that is one of the places that can cause an issue. Because if you don't close that parentheses after the 19, the calculator is going to add the 19 and 3 first, then apply the log to it, and then divide by 4, which is not what we're saying. We want log of 19, its value added to 3, 3 added to it, and divided by 4. So whenever you type ln of 19, you want to make sure close that parenthesis before typing it in. Any other questions on this here? Are these as bad as what they look like to start with? Not too bad, really. We're just applying e or log and then using what we've been doing with solving equations. We're ready for what's next. So this is the next one that we have. This one's a little bit different because this time we're not starting with an exponent, we're starting with a logarithm. Now we looked at our properties, because one of the first properties we had was log base b of b is equal to 1, and that's the one we've been utilizing thus far to solve all of these here. Now the other one that we had was b to the log base b of x is equal to x. If we have an exponent to a log with the same base as what the exponent is, these cancel out, they undo each other, leaving us with what's inside. So looking at this problem here, what is the base of the log? 2. So if we had 2 to the log base 2 of 5x minus 17, that 2 and that log base 2 would simplify out. They would cancel each other out. These here would cancel each other out, leaving us with what's inside the log, which would be 5x minus 17. But what we do to one side, we have to do to the other. So on the other side, we're going to have 2 to the third. Well, luckily, we can type 2 to the third power in the calculator, or we can do it by hand. 2 times 2 is 4, times 2 is 8. Now we just need to solve for the value of x. So the first thing we can do is Add 17 to both sides, because negative 17 plus 17 is 0. Telling us that 5x is equal to, and then we would divide both sides by 5, telling us x is equal to 5. And that right there is our answer. One thing we do have to be careful with logarithms is that what's inside the log cannot be 0 or negative. What's inside of a logarithm cannot be 0 or negative. So it's sometimes good to check it. 5 times 5 minus 17. Well, 5 times 5 is 25. And 25 minus 17 is 8. Okay. And that does work. And I mean, we could type log base 2 of 8 in the calculator, and it will come out to be 2. Or not 2. I don't know why I've been writing 2, because it was 3. Yeah, there should have been 3, not 2. But it still works out. We still get a positive number inside the log, and it does equal here 3. Because what our final number, whenever we plug the value of x in, cannot be negative or 0. The value of x can be negative or 0 as long as it works out that once we plug it back in, that what's in the final simplified version of each log is not negative or 0. Does that make sense? Any questions on this here? Let's look at the next one. So knowing what we did on the last one, what can we do in simplifying this here? Well, we would give both of them a base of 3. The terminology for this is kind of weird, because what we're doing with this here is something we really haven't done before, applying a base to both sides. And the reason we're doing this is because log base 3 to the log base 3 is what? Well, they cancel out. That simplifies to 1, leaving us with 10x minus 9. These here, 3 to the log base 3, cancel. That's why we're doing this. On the other side, we have 3 to the 4th. 3 to the 4th power is 81. Because 3 times 3 is 9. 9 times 9 is 81. 3 squared times 3 squared is 3 to the 4th. Now we just need to solve for the value of x. So we would add 9 to both sides. And if we add 9 to both sides, we get that 10x equals 90. What would we do next? Divide both sides by 10. X equals 9. That's it. And if we plugged it back in, we will get a true statement. Any questions on any of this here? So are there any other questions on this one here? Any other questions on these here? Because we feel comfortable with these here, yes? Okay. So let's look at the next one. Now, for any of these to work, we really need only one log, or one term on either side. Here we have 2, yes? But one of our other properties of logarithms stated if I have the same logs, not what's inside, but the same log here, log and log are the same, and they're being added together, we can rewrite it as a single log with what's inside being what? Multiplied together. So we can rewrite log of 2x plus log of x minus 5 as log of 2x times x minus 5. So if I have 2 of the same logs being added together, we can rewrite it as one logarithm with what's inside being multiplied. Any questions on that first main step? Because really after that step, it's going to be exactly what we did on the last one. Now what's the base for this log? 10, because if it's not written, it's understood to be 10. So here we're going to put a base of 10 to both sides. Because here 10 to the log cancels out, telling me I just have 2x times x minus 5 is equal to 100. Because 10 squared would give us 100. Any questions on any of this here? So at this point, we're trying to find out what value of x is going to make 2x times x minus 5 equals 100. Well, it might be a little bit easier if we multiplied the left-hand side out. 2x times x is going to give us 2x minus 2x times negative 5 is negative equals 100. Well, we have a quadratic, because anytime, so the x squared tells us we have a quadratic. Whenever we have a variable with a degree or an exponent greater than 1, we need to get everything on the same side of the equal sign. So what we can do is subtract 100 from both sides, telling us that 2x squared minus 10x minus 100 is equal to 0. Any questions on how we got to this point here? Now, there's 3 different ways we can go about solving this quadratic. We can use the quadratic formula, we can factor it, or we can graph it. Which way do y'all want to do? Why don't we try graphing first? Because whenever we graph it, we're just looking for what value of x is going to make this function equal what? 0, yes? So we can type in 2x squared minus 10x minus 100. We're just trying to see where the y value is 0. Well, zoom standard. Okay, so if we look at this here, we can see it looks like it does hit 2 whole numbers nicely, yes? So if I go second graph, looking at a table, I'm looking for where y1 is 0. Now we did see one negative value, negative 5. So one of the solutions for this here is negative 5. Now we'll scroll down some to get the other one. And the other value is x equals 10. When we graphed it, it was kind of nice because it told us x is negative 5 or 10. We could have factored this and got x plus 5 times x minus 10 as our solutions. But our original equation was log of 2x plus log of x minus 5, yes? Now again, what's inside the logarithms cannot be 0 or negative. And whenever we check this, we always check it with the original problem, nothing that we applied to it. So log of 2x times x minus 5, we've applied a property to it. We're looking back at this one here. So if I start off with negative 5, log of 2 times negative 5 plus log of negative 5 minus 5 equals 2. Well, 2 times negative 5 is negative 10 plus log of, do I have a negative inside the log? Yes. So that tells me that negative 5 does not work. It is not a solution. But if we check with log of 10, log of 2 times 10 plus log of 10 minus 5, we would get log of 20 plus log of 5. This here works. We do have two whole numbers, and they are positive inside the logarithm. And if I grab the calculator to check this, log of 20 plus log of 5, help if I get out of that, log of 20 plus log of 5, and hit enter, we get 2. So it does work, but negative 5 does not. Because if I do log of negative 10 plus log of negative 10, non-real answers. It does not work. Any questions on this here? Any question on everything we've done so far? So even if we get the same thing on both sides, what's inside the logarithms cannot be negative or 0. Those do not work. Are we ready for the next one? Now for this one here, we do have two logs being added together. So we can rewrite it as a single logarithm with what's inside being multiplied. Now what can we do next? Well, we can apply what? A base of 6 to both sides, because 6 to the log base 6 will cancel out, telling us that 6x times 1 is equal to 36. Now on the left-hand side, we'll have to distribute the 6x. So 6x times x is 6x squared minus 6x equals 36. Well, anytime we do have an x squared or a variable with a power greater than 1, we do need to get everything on the same side. So we can subtract 36 from both sides, which will tell us that 6x squared minus 6x minus 36 is equal to 0. Now at this point here, we could try to graph it, use the quadratic formula, or factor it. Factor it or graph it. We can graph it. And we can type it back in, 6x squared minus 6x minus 36 was equal to 0, yes? We can hit graph. Nicely enough, we do look like we have two whole number points. So if I want to get a better look at that, I can look back at the table. Yep. Table set. So one of our values is -2 and the other is 3. Three and -2. Which value do we know won't work? -2. Now, one of the best ways to look at it to check and see is if I look at both 6x and x minus 1, is there anything in either one of those places that's going to take that negative and make it positive? No, 6 times a negative is still going to be negative. A negative minus 1 is still going to be a negative number, yes? So there's no way the negative would work. If it was, say, negative 6x and negative 1 plus, or negative x plus 1, then the negative could work because there's something to offset it. Here, there's nothing. So it's just telling us x is equal to 3. Now, we did run out of time. We will finish these note sheets at the start of class tomorrow. And I'm going to tag the other part of 6 into it because there's only 3 problems with 6.63. It's using the other part instead of addition. It's going to be our subtraction, our division property.